Principles and cycles of air conditioning. Basic principles. Hello folks, welcome to today's lecture on principles and cycles of air conditioning. The basic principle of air conditioning is centered around thermodynamics and fluid mechanics. It involves a continuous cycle of compression, condensation, expansion, and evaporation of a refrigerant to absorb heat from the indoor environment and expel it outside. Refrigeration cycle. The refrigeration cycle consists of four essential processes. Compression. The refrigerant gas is compressed by the compressor, raising its temperature and pressure. Condensation. The high-pressure refrigerant gas passes through the condenser coils where it releases heat to the outside air and turns into a liquid. Expansion. The high-pressure liquid refrigerant flows through an expansion valve where its pressure drops, cooling it significantly. Evaporation. The cold liquid refrigerant absorbs heat from the indoor air as it evaporates within the evaporator coils, cooling the inside air. Thermodynamic laws. The operation of an air conditioning system is governed by the laws of thermodynamics, particularly the second law, which states that heat will naturally flow from a hotter body to a cooler one unless external work is done to reverse this flow. Components and accessories. Main components. Compressor, often considered the heart of the system, it pumps the refrigerant through the system. Condenser facilitates the discharge of absorbed heat to the external environment. Expansion valve reduces the pressure of the refrigerant, allowing it to expand and cool before entering the evaporator. Evaporator coil absorbs heat from the indoor air, providing cooling. Additional accessories. Thermostat controls the temperature setting for the air conditioning system. Air filters remove dust and impurities from the air before it enters the system. Ductwork distributes conditioned air throughout the building. Fans assist in air circulation across the different components. System design and installation. Design considerations. Effective air conditioning system design must take into account various factors such as the size of the area to be cooled, the number of occupants, ambient climate conditions, and energy efficiency goals. Load calculation. Understanding the thermal load is fundamental. This includes considering the heat generated internally by occupants, lights, and equipment, as well as external sources like sunlight and ambient temperature. Installation process. Site assessment. Conduct a comprehensive survey of the installation site. System sizing. Choose the appropriately sized unit based on the calculated load requirements. Component placement. Install components like compressors, condensers, and evaporators in optimal locations for performance and efficiency. Connection of ductwork. Ensure proper installation and sealing of ducts to avoid air leaks. Calibration. Set up and calibrate thermostats and other controls to achieve desired performance levels. Maintenance and efficiency. Regular maintenance of the air conditioning system is critical to ensure its efficiency and longevity. This involves routine cleaning of filters, checking for refrigerant leaks, and inspecting electrical components. Tips for energy efficiency. Ensure regular cleaning and replacement of air filters. Seal any leaks in ductwork to prevent energy loss. Utilize programmable thermostats to optimize usage. Consider upgrading to modern, energy-efficient units. By understanding the fundamentals of air conditioning systems, their components, design, and installation processes, individuals working in this field can enhance both the performance and efficiency of fixed systems in residential and commercial settings. Executive summary. Here's a summary of the principles and cycles of air conditioning. Principles of air conditioning. 1. Heat transfer. Air conditioning involves transferring heat from one location to another. 2. Thermodynamic properties. Air conditioning relies on thermodynamic properties of refrigerants such as temperature, pressure, and entropy. 3. Refrigerant. A refrigerant changes state liquid to gas and vice versa to absorb and release heat. 4. Humidity control. Air conditioning controls humidity levels to maintain a comfortable indoor environment. Air conditioning cycles. 1. Vapor compression cycle, the most common cycle, involving compression, condensation, expansion, and evaporation. 2. Absorption cycle, uses heat energy to drive the air conditioning process. 3. Evaporative cycle, uses water evaporation to cool the air. 4. Desiccant cycle, uses a desiccant material to remove moisture from the air. Key components. 1. Compressor, compresses the refrigerant, raising its temperature and pressure. 2. Condenser, cools the compressed refrigerant, causing it to condense into a liquid. 3. Expansion valve, reduces the refrigerant pressure, allowing it to expand and become cold. 4. Evaporator, allows the cold refrigerant to absorb heat from the surrounding air. Air conditioning system types. 1. Window unit, a self-contained unit installed in a window. 2. Split system, separates the compressor and condenser from the evaporator. 3. Packaged unit, a self-contained unit housing all components in a single cabinet. 4. Central air conditioning, uses ducts to distribute cooled air throughout a building.
Here's a summary of refrigerator components and accessories. Major components. 1. Compressor, compresses refrigerant, raising temperature and pressure. 2. Condenser coils, cool compressed refrigerant, causing condensation. 3. Expansion valve, reduces refrigerant pressure, allowing expansion and cooling. 4. Evaporator coils, allow cold refrigerant to absorb heat from surrounding air. 5. Insulation, reduces heat transfer between cold interior and warm exterior. Electrical components. 1. Motor, powers compressor and fan motors. 2. Fan motors, circulate air over condenser and evaporator coils. 3. Relays, control compressor and fan motors. 4. Thermostat, regulates temperature inside refrigerator. Accessories. 1. Shelves, provide storage space for food and drinks. 2. Drawers, offer additional storage space for fruits, vegetables, and meats. 3. Door seals, ensure tight seal between door and refrigerator cabinet. 4. Ice maker, automatically makes ice cubes. 5. Water dispenser, provides a convenient source of chilled water. Other components. 1. Refrigerant, substance that changes state to absorb and release heat. 2. Capillary tubes, regulate refrigerant flow into evaporator coils. 3. Defrost timer, controls defrost cycle to prevent ice buildup on evaporator coils. 4. Drainage system, collects and drains condensate water from the defrost cycle. Here's a summary of refrigerator system design and installation. Design considerations. Design considerations. 1. Load calculation, determine required cooling capacity based on factors like room size, insulation, and desired temperature. 2. Refrigerant selection, choose suitable refrigerant considering factors like efficiency, safety, and environmental impact. 3. Compressor selection, select compressor matching required cooling capacity and operating within the desired temperature range. 4. Condenser coil design, design condenser coil ensuring efficient heat rejection and minimizing pressure drop. 5. Evaporator coil design, design evaporator coil ensuring efficient heat absorption and minimizing pressure drop. 6. Insulation and cabinet design, design insulation and cabinets to minimize heat transfer and ensure structural integrity. 7. Airflow and ventilation, ensure proper airflow and ventilation to prevent moisture buildup and reduce energy consumption.
Installation considerations. 1. Location, install refrigerator in well-ventilated area, away from direct sunlight and heat sources. 2. Leveling, ensure refrigerator is properly leveled to prevent uneven cooling and reduce energy consumption. 3. Connections, connect refrigerator to suitable power source and ensure all electrical connections are secure. 4. Refrigerant charging, charge system with recommended amount of refrigerant to ensure optimal performance. 5. Leak testing, perform leak testing to ensure system is leak-free and operating efficiently. 6. Electrical and safety considerations, ensure compliance with the electrical and safety codes and install necessary safety devices. System components installation. 1. Compressor installation. Install compressor in well-ventilated area, ensuring proper mounting and connections. 2. Condenser coil installation. Install condenser coil in location, ensuring efficient heat rejection. 3. Evaporator coil installation. Install evaporator coil in location, ensuring efficient heat absorption. 4. Expansion valve installation. Install expansion valve in location, ensuring proper refrigerant flow. 5. Capillary tube installation. Install capillary tube to regulate refrigerant flow. In conclusion, the principles and cycles of air conditioning are based on fundamental thermodynamic principles that enable the transfer of heat from one location to another. The basic principles of air conditioning include heat transfer. Heat transfer is the fundamental principle behind air conditioning, where heat is transferred from a colder body to a hotter body. Thermodynamic properties. Air conditioning relies on the thermodynamic properties of refrigerants such as temperature, pressure, and entropy. Refrigerant. A refrigerant is a substance that changes state liquid to gas and vice versa to absorb and release heat. Humidity control. Air conditioning also involves controlling humidity levels to maintain a comfortable indoor environment. Key components. The key components of an air conditioning system include the compressor, condenser, expansion valve, and evaporator. Air conditioning cycles. The air conditioning cycles include the vapor compression cycle, absorption cycle, evaporative cycle, and desiccant cycle. System types. Air conditioning systems can be classified into window units, split systems, packaged units, and central air conditioning systems. Understanding these principles and cycles is essential for designing, installing, and maintaining efficient and effective air conditioning systems. Thank you for taking this lesson. We hope to have you again in the next lecture. Happy learning, folks!